For now, we will see the function of the special right triangle to a 6 trigonometric ratios. We will see if they are really a special right triangle. Let's say, for example, look at this one. We will review it first. This one is a 30, 60, 90. This is 60 degrees. And the other one is 30 degrees. This is opposite to a shorter leg. And the 60 is opposite to a longer leg. We will assign a value for SL, or the shorter leg, as A. That is the length of shorter leg A. The length of longer leg is A square root of 3 based on the formula. And the hypotenuse is double the shorter leg. So let's say, for example, this is the 60 degrees. And this one is the 30 degrees. Let's make it 5 as our shorter leg. What would be the longer leg? The longer leg now is 5 square root of 3. How about the hypotenuse? That is 10. And another example, using the same formula, let's make it 8. That is the shorter leg, and it is opposite to 30 degrees. The longer leg is opposite to 60 degrees. This is now 8. That is A square root of 3. And the hypotenuse is double the shorter leg, and that is 16. We will compare the two figure with different values of sides if the 6 trigonometric ratios will also change. So let us see. We will be using the primary ratios, which is sine. For the meantime, we will be using the 30, cosine 30, and tan 30. We will get the value of sine 30, cosine 30, and tan 30 using this figure. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. In sine 30, what is the opposite? That is 5 over hypotenuse is 10. And the result here is, as we divide 5 and 10, it is 1/2. And the adjacent here is cos 30. Cos 30 is adjacent is 5 square root of 3 over hypotenuse is 10. And the result is 5 and 10. 5 divided to 10 is 1 over 10. 1 over 2, or that is square root of 3 over 2. For the tan 30 opposite is 5. And the adjacent is 5 square root of 3. And the result is 5 divided to 5 is 1 over square root of 3. Since the denominator is square root of 3, rationalize them. Square root of 3 over square root of 3. The result is square root of 3 over 3. Because square root of 3 times square root of 3 is 9, and the square root of 9 is 3. So we will compare this one to the value of the ratio of sine 30 degrees cos 30 degrees and tan 30 degrees of this figure, whether they will get the same answer, even they have different length of sides. This is opposite over hypotenuse. In sine 30, the opposite is 8. We will be using that opposite. 8 over the hypotenuse is 16. And the result is 1/2. As you can see, we have different values of length, but we get the same ratio, under 30 degrees. And for cos theta, a cos 30 degrees, opposite, adjacent, square root of 3 over the hypotenuse. That is square root of 3 over 8 divided to 16 is 2. So we get the same answer also. Square root of 3 over 2. For the tan theta, that is opposite over adjacent. The opposite here is 8. And the adjacent is 8 square root of 3. And the result here now is 8 divided to 8 is 1 over square root of 3. Rationalize them. Square root of 3 over square root of 3. And the result is 1 times square root of 3 is square root of 3. And square root of 3 times square root of 3 is square root of 9, or that is 3. Using 6 trigonometric ratios, we were able to find that every ratio are similar as long as it is under 30, 60, 90 right triangle. For this example, we will be getting another ratio of the 6 trigonometric ratios, which are the cosecant 30 degrees, the secant 30 degrees, and cotangent 30 degrees of this first illustration. The cosecant 30 degrees has a ratio of hypotenuse over opposite. The hypotenuse to 30 degrees is 10. That is 10. And the opposite here is 5. So the cosecant 30 degrees is 2. And the secant 30 degrees is hypotenuse over the adjacent. The hypotenuse here is 10. And the adjacent here is 5 square root of 3. And that is 10 divided to 5 is 2 over square root of 3. Since the denominator is a radical, rationalize it, square root of 3 over square root of 3. The result is 2 square root of 3 over 3. That is the secant 30. The next is, for the cotangent 30 degrees has a ratio of adjacent over opposite. In 30 degrees, the adjacent here is 5 square root of 3 over the hypotenuse here is 10. The opposite here is 5. So the answer here is 5 divided to 5 is 1. So it is square root of 3. So the value of cosecant 30 is 2. The value of secant 30 is 2 square root of 3 over 3. And the value of cotangent 30 is square root of 3. We will see if these values is also the same with the value of another illustration. So let's see. Cosecant 30 degrees. The cosecant is hypotenuse over the opposite. So this is 16 over the opposite is 8. So the answer is 2. So the two are the same. The secant 30 degrees is equal to the hypotenuse over adjacent, and the hypotenuse here is 16, and the adjacent is 8 square root of 3. So the result here is 16 divided to 8 is 1/2, or 2 over square root of 3. Rationalize the denominator, square root of 3 over square root of 3. The result is 2 square root of 3 over 3. And the cotangent 30 degrees is adjacent over opposite. The adjacent here is 8 square root of 3. And the opposite here is 8. So this is now 8 divided by 3 is 1. 8 divided by 8 is 1. And the remaining now is square root of 3. So as you can see, even the secondary ratios are similar. Cosecant of the first illustration is 2. The cosecant 30 of the second illustration is also 2. So when we are in 30, 60, 90, this is always applicable. For this illustration, we will be getting the 60 degrees for the 6 trigonometric ratios. So we have sine 60 degrees. Sine is equal to opposite over hypotenuse. So opposite over the hypotenuse. the opposite to 60 degrees is 5 square root of 3. The hypotenuse is 10. And sine 60 degrees now is 5 divided to 10 is 1/2, or that is square root of 3 over 2. So this is the value of sine 60 degrees. So take note that this value will always remain under 30, 60, 90 degrees. Cosine 60, that cosine 60 now is adjacent over hypotenuse. And the adjacent here is 5. And the hypotenuse is 10. And the answer here is 1/2. For the tan 60 degrees, that is opposite over adjacent. And the opposite to 60 degrees is 5 square root of 3. And the adjacent is 5. And the answer here will be 5 divided by 5 is 1. So we only have square root of 3. For the cosecant 60 degrees, cosecant is the inverse of sine, hypotenuse over opposite. The hypotenuse here is 10, and the opposite here is 5 square root of 3. And the result here is 10 divided by 5 is 2 over square root of 3. So we have the denominator that is radical. Rationalize them by multiplying numerator and denominator by square root of 3. So the result is 2 square root of 3 over 3. For the secant 60 degrees, that is hypotenuse over adjacent. The hypotenuse again is 10 and the adjacent is 5. So the answer here is 10 divided by 5 is 2. And the last one, we have the cotangent 60 degrees, and that 60 degrees is the same as adjacent over opposite, and the adjacent here is 5 and the opposite is 5 square root of 3. So the result here is 5 divided by 5 is 1, so 1 over square root of 3. Rationalize it, so the answer will be square root of 3 over square root of 3. The result is square root of 3 over 3. These are the values of sine 60, cosine 60, tan 60, cosecant 60 degrees, secant 60 degrees, and cotangent 60 degrees. This is a 45-45 90 right triangle. So the two legs are equal. So we are using the formula. Leg is like A, and this is A times square root of 2. This is the formula in getting the side of a right triangle under special right triangle. So let's say, for example, with this illustration, this is 4. Automatically, the other one is also 4. And the hypotenuse here is 4 times square root of 2. For another example, let's say, for example, this is 6. Automatically, the other one is 6. So this is 6 square root of 2. And this is under 45 degrees, 90 right triangle, 45 degrees, 90 right triangle. We'll now get the sine 45 degrees. Sine is opposite over hypotenuse. And the opposite to 45 degrees, since it is there is only one measures of angle, which is 45. So opposite over hypotenuse. Let's say, for example, we will stick on this triangle or in this angle. opposite is 4, and the hypotenuse is 4 square root of 2. So the result here is 1 over square root of 2, because 4 divided by 4 is 1. We only have square root of 2. Rationalize it. So the result is square root of 2 over 2. As we get cos 45, the ratio for cos 45 is adjacent over hypotenuse. Adjacent is 4, and hypotenuse here is 4 square root of 2. So the two are similar, so automatically the final answer here is square root of 2 over 2. For tan 45 is opposite over adjacent. So the opposite here is 4, and the adjacent is 4. So the result is 1. This is now the value of sin 45 is square root of 2 over 2, cos 45 is square root of 2 over 2, and tan 45 is 1. So let's check if using another figure or length of the other sides is different. So definitely if we will get the same answer. Let's see, sine 45 degrees, and we will use the same reference angle here. This will be a reference angle. Opposite here is 6, and the hypotenuse here is 6 square root of 2. This is now 1 over square root of 2, or it is square root of 2 over 2, because they are same or similar. For the cosine 45, this is adjacent is 6 over the hypotenuse. Again, the two are similar, so at the end we have square root of 2 over 2. For the tan 45 degrees, this is opposite over adjacent. The opposite is 6, and the adjacent is 6. The result is 1. As you can see, whatever the length of the given right triangle, as long as it is under 45, as we get the ratio, the sine, cosine, tangent as our primary ratio, the answer are always the same. As we continue this one, let's say we will get the cosecant. The cosecant 45. Let's say we will get the cosecant 45. Cosecant 45 degrees. The cosecant 45 degrees is hypotenuse over opposite. So the hypotenuse is 4 square root of 2, and the opposite here is 4. So the result here is 4 and 4 is 1. So that is now square root of 2. For the secant 45, that is hypotenuse over adjacent. The hypotenuse again is 4 square root of 2, and the adjacent is 4. The result is square root of 2 also. For the cotangent 45, that is adjacent over opposite. The adjacent here is 4, and opposite is 4. The result is 1. So these are the values now of cosecant 45 is square root of 2, secant 45 is square root of 2, and cotangent 45 is 1. And for the another figure, we have the cosecant 45 degrees, which is hypotenuse over opposite. The result is square root of 2. And for the secant 45 degrees, we have hypotenuse over adjacent, 6 square root of 2 over 6. The result is also 2. And for the cotangent 45 degrees, that is adjacent over opposite, 6 over 6, the result is 1. And as you can see, we get the same answer also. And this is the summary of our lesson. So always remember that since we are under special right triangle, whenever we get the sine 30 degrees under 30, 60, 90, 30 degrees is always equal to 1/2. Cosine 30 degrees is always equal to square root of 3 over 2. Tan 30 degrees is always equal to square root of 3 over 3. And cosecant is always equal to 2. Secant 30 degrees is always equal to square root of 3 over 3. And cotangent 30 degrees is always equal to square root of 3. For the 60 degrees, sine 60 degrees is always equal to square root of 3 over 2. For the cosecant 60 degrees always equal to 1/2. Tan 60 degrees always equal to square root of 3. And cosecant 60 degrees is always equal to 2 square root of 3 over 3. For the secant 60 degrees always equal to 2. And the cotangent 60 degrees is always equal to square root of 3 over 3. So this is the summary of the values of the special right triangle of 60 degrees. For the 45, 45, 90 degrees, the value of sine 45 degrees is square root of 2 over 2. The cosine 45 is square root of 2 over 2, so the two are similar. The tan 45 degrees is 1 only. For the cosecant 45 degrees, it is equal to square root of 2. And secant 45 degrees is square root of 2. And cotangent is 1. This is the values of 6 trigonometric ratios if the angle has the measure of 45 degrees. So always remember them.